Okay, let's talk forms. I mean, they're absolutely central to, well, almost every modern web application, aren't they?
Oh, definitely. Think about it. Social media posts, e-commerce orders,
Right, exactly. Signing up for anything.
all that data capture, it's all forms.
Yeah.
For anyone building these apps, getting that input right
Yeah, managing the state, the validation.
and making sure it actually performs well and scales up. That's fundamental. It's really the bedrock.
But, and this is the kicker, if you try doing complex forms just with like native React state,
Yeah.
it gets messy fast.
Oh, it's a nightmare. You end up writing all this custom fragile validation code field by field.
Yeah, it becomes a real minefield.
It does. And that's why we're doing this deep dive today. We're looking at the source material because, frankly, we need a better way, a clear, high-performance standard.
So the mission today.
The mission is to really understand why React Hook Form, RHF, has kind of become the go-to standard in the industry.
And distill what you, the learner, actually need to know to start building, well, better, faster forms right away.
Exactly. Let's get into it.
Okay, let's unpack the pain first. Those technical pitfalls of just, handling forms the native React way. I think every dev listening has felt this. That huge state object.
Trying to track a dozen fields, their errors, touched states.
Yeah.
It's chaos.
That chaos is very real. And the sources point out two immediate technical problems. First off, with native useState, there's just no clear standard.
Right, like should I use 10 different useState hooks or
Yeah.
one giant state object?
Precisely. Developers are forced into these arbitrary choices right from the start. There's no defined best practice there.
Okay, and what's the biggest performance hit, the thing that really slows you down with that native approach?
It's what the sources call the re-render trap. It's critical. When you use standard controlled components tied to useState.
Which is the common way, right?
The most common way, yes. Every change you make, literally every single keystroke, triggers a state update.
Which means,
It forces a re-render of the component holding that form state.
ouch. So for a big form, if you've got a large form, especially if it's not, perfectly memoized, that constant re-rendering, it can be disastrous for performance, really slow things down.
Okay, so performance is one big issue.
Yeah,
But the chaos, it goes beyond just speed, right? Validation is another headache.
absolutely. There's just no standard way to define validation rules natively, even simple ones.
Let alone the complex stuff, like checking one field based on another.
Right. And the moment you need something slightly more complex, like, say, only showing an error after the user has actually interacted with the field, with the touched state,
Yeah, that's a common requirement.
you immediately have to add more state variables just to track interaction. Not even the value itself, the logic just explodes.
And you end up writing custom functions that are different depending on when you validate, on change, on blur, on submit.
Exactly. It's bespoke logic everywhere.
So this lack of a standard,
Yeah.
it doesn't just make initial development tricky, it sounds like it creates long-term fragility.
Precisely. When every developer on a team, or even just you working alone over time, uses a slightly different strategy for state or validation, the application just lacks uniformity.
Harder to maintain, harder to debug.
Definitely. The sources warn that this kind of custom native logic is often filled with subtle performance flaws, flaws that might not bite you immediately, but they really hurt in the longer run.
Making bug fixes or adding new features way more difficult and error-prone than they need to be.
We need something better. We need standardization, we need robustness tested by many, and scalability built in.
Okay, that's the perfect setup. It brings us right to React Hook Form. So we need a fundamental shift away from these problems. What's the core architectural difference? What makes RHF inherently faster than, say, older libraries like Formic that still rely heavily on state?
Okay, the key architectural advantage, the big one, is refs versus state.
Refs versus state.
Yes, RHF is built around the concept of using uncontrolled components. This is crucial. It doesn't manage the form values using React's state system while you're typing.
Wait, so if I type into an input field that's managed by RHF, does that mean no state update? No re-render cycle?
That's the core technical insight, exactly. Typing into an RHF input field does not trigger a re-render of your form component.
How does it track the value then?
It uses refs, those low-level references to the DOM nodes. It only accesses the current values via these refs when it actually needs them, like during submission.
Ah, so it bypasses the React update cycle for input changes. That sounds dramatically fast.
It is dramatically faster than state-based solutions. And components generally mount faster, too, because there's just less initial overhead.
Okay, performance, check.
Yeah.
Big win there. But what about the developer side? Code quality, maintainability, just
Good point.
reliability.
RHF tackles that head on, too.
Yeah,
First big point. It's built entirely in TypeScript.
which gives you...
End-to-end type safety right out of the box.
Mm,
If you define a type for your form data, like a form data interface,
yep.
RHF ensures that every function, every return value sticks to that structure. You get great linting, fantastic autocompletion,
And it catches errors.
catches those simple but sometimes costly mistakes instantly, like, trying to pass a Boolean value to a field that's expecting a string. TypeScript catches that before you even run the code.
That preventative safety that's huge for development speed, for just confidence.
Absolutely. And then on the maintenance and ecosystem side, the metrics are really quite compelling.
Like what?
Well, for one, RHF has 0 dependencies.
0.
0 third-party dependencies. That's massive for reliability. It means fewer potential bugs coming from somewhere else in the dependency chain, and it keeps the actual library size incredibly small.
Okay, that's impressive. And what about popularity? Does the community back this up?
Hugely. The sources note that around the time they were written, RHF had something like 5 million weekly NPM installs.
Wow. How does that compare?
It was roughly double its closest counterpart, Formic, which was sitting around 2.7 million at the time.
Okay, so serious adoption. And is it actively maintained? That's always a concern with libraries.
Very actively. The sources highlighted that RHF's latest commits were often just a day or two old.
Compared to back.
Compared to competitors where the last commit might have been months or sometimes even a year prior. That tells you a lot about the ongoing support and development effort.
And one more indicator.
GitHub issues. RHF had a remarkably low number of open issues. I think the source mentioned just 1 open issue at the time of writing.
1. Compared to hundreds for others.
Exactly. It's a strong signal of a really robust, well-tested, and trustworthy library. It's become the standard for a reason.
All right, I'm sold on the why. RHF is the architectural champ. Now, let's pivot to the how. For the learner listening wanting to start building forms today, it all starts with one hook, right? The useForm hook.
That's your entry point. useForm, you call that hook, and it basically returns an object containing everything you need.
Like the tools for the job.
Pretty much. The functions to connect your inputs, the handlers for submission, the form state-like errors. It's all in there.
And if you're using TypeScript...
You pass your form data type as a generic right there to useForm. So like useForm my form data.
Yeah.
That enforces type safety across everything the hook returns and uses.
Okay, so we call useForm. How do we actually connect, say, a standard HTML input element to this RHF system? Since we're not using state and onChange in the traditional way, that must be where register comes in.
Register is the key. It's the function that does the binding. You call it, pass it a unique string that's the name of your field, like email or password.
And it returns.
It returns an object with the props that the input needs. Things like onChange, onBlur, name, and crucially, ref.
Ah, the ref.
Exactly. So you just spread the result of that function call onto your input element, like input.register email. That's it. It wires the input up to RHF's internal tracking using that ref.
Nice and clean. And I saw it handles basic validation, too.
It does. As an optional second argument to register, you can pass an object with validation rules. Super simple things like required true or min length. 8.
Convenient. What about type handling? Like if an input is for a number?
Also handled there. You can add properties like value as number.
Right, true.
RHF will then automatically try to parse the input string into a number type for you when you get the form values. Really useful for quantity fields, age, things like that.
Okay, inputs are registered, maybe with some basic validation. Now we need to submit the data safely. That's handle submit's job.
Handle submit is essentially your gatekeeper for submission. You wrap your own submission handler function with it.
So on the forms on submit event, you call handle submit and pass your function to it.
Correct. And here's the critical part. RHF's handle submit will only call your provided function if all the registered field validations pass successfully.
Ah, so it prevents you from even trying to submit if there are errors.
Exactly. No need to manually check for errors in your submit handler. It saves you from potentially sending bad data to your backend, running unnecessary requests. It handles both sync and async submission functions gracefully too.
Okay, that makes sense. But since we're not using React State for the input values themselves, how do we track other important UI states like, is the form currently submitting? Or has the user actually changed anything? We need that for disabling buttons and stuff.
Good question. That's where the form state object comes in. It's another property returned by useForm.
And what's in form state?
It contains all those crucial UI context flags, things like errors, object-containing validation errors, I-loading for async default values, is valid, is the form valid right now, is dirty, has any field changed from its default, and is submitting.
So you'd use is dirty and is submitting to control the submit button's disabled state, for instance.
Exactly. Disable if is submitting is true, or maybe disable if is dirty is false, meaning the user doesn't actually change anything yet. It gives you all the necessary flags for that kind of UI logic.
Let's circle back to performance quickly. We established RHF avoids re-renders on input because it uses reps and uncontrolled components. But what if I need to react to a value change? The classic example. The checkbox is shipping, same as billing. If I uncheck it, I need to show the shipping address fields. How do we do that without re-rendering the whole form?
Right. That requires subscribing to value changes. RHF provides a function called watch for this. You can use watch field name to get the current value of a field.
Okay.
But T, and this is a big, be very careful to watch, if you call watch inside your main form component,
Let me guess. It causes a re-render.
it causes the entire form component to re-render whenever that watched value changes, which kind of defeats the main performance benefit of RHF in the first place.
Oof. Okay, so watch is potentially a performance trap if used incorrectly. What's the right way, the optimized way for that dependent field scenario?
The optimized solution, the essential performance insight here, is to use a dedicated hook. Use watch.
Use watch. How's that different?
You use watch typically inside a child component that needs to react to a specific field's value from the parent form. By using use watch within that child, only that child component will re-render when the watched value changes.
Ah, so it isolates the re-render. The main form component stays untouched.
Exactly. It keeps the performance benefit intact by containing the re-render just to the specific part of the UI that actually depends on that changing value, like your conditional shipping address section. That's key for scaling performance in complex UIs.
That is a fantastic, really practical takeaway. Use watch for targeted updates.
Okay, let's talk scaling complexity further, advanced validation, and structuring larger forms.
Right. So beyond the basic rules and register, RHF gives you more validation power. You can provide custom error messages directly. Instead of just required, true, you can do required. Hey, we need your email address.
Nice for user experience. What about checks that aren't just simple constraints, like maybe a password needs a special character, or you need to check if a username is unique by calling an API? For that kind of custom, complex logic, Register offers a validate property. This can accept a function, or even an object of named validation functions.
And these functions can do anything.
Pretty much anything you need. They receive the field value and should return true if valid, or an error message string if invalid. Crucially, these validation functions can even be asynchronous.
Async. So you could actually await an API call inside validate.
Yes, perfect for checking things like email uniqueness against your backend during validation before the user even hits submit. Very powerful.
Okay, that's cool for custom rules. But often, for really complex forms, the best practice is to define validation using schema libraries, right? Like yup or zod. How does RHF play with those?
It integrates beautifully. That's generally the recommended approach for complex validation using a schema library. RHF has a separate package, a hook form resolver.
Resolvers.
Yeah, you install that, and it provides resolver functions for popular schema libraries like Zod, Yep, Joy, etc. You create your Zod schema, for example, then you pass it to the Zod resolver function from the package.
And where does that go?
You plug that into the resolver option in your main useform hook call. So useform resolver, Zod resolver.
So RHF just delegates all validation logic to your Zod schema. That keeps the validation logic really clean and separate.
Exactly. Centralized, reusable, and leverages the power of those dedicated schema validation libraries. It's the standard for robust validation.
Makes sense. Now, structuring large forms. If I have, say, a reusable chunk of fields like login, credentials, email password that I use in multiple places, how do I avoid passing RHF methods down through lots of props, that whole prop drilling nightmare?
Yeah, prop drilling is painful. RHF solves this using React's context API, basically. It provides a component called form provider.
Form provider?
You wrap your main form component with form provider.methods, where methods is the object returned from your top-level useCom call.
Okay, so it puts the form methods into context.
Precisely. Then any component nested deep inside that provider tree, like your reusable credentials component.
It can just access the methods.
You can just call another hook, use form context, and it gets access to all the RHF methods like register, form state, etc., without any props being passed down explicitly.
Clean. Very clean. Okay, what about dynamic lists? like adding multiple phone numbers or line items on an invoice, managing arrays of fields.
For that, RHF gives you the useFieldArray hook. It's specifically designed for managing dynamic lists of fields.
How does it work?
You call useFieldArray, passing it the control object from useForm and the name of the array field, e.g. phone numbers. It returns an object with the current field's array and utility functions.
Utility functions
Like append, prepend, remove, insert, swap, move, replace, all the standard array manipulation things you need. It makes managing those dynamic structures much, much simpler than trying to handle that array state manually.
Okay, that sounds essential for complex data entry. One last best practice for scaling. Integrating with third-party UI libraries. Material UI, Chakra, whatever. Their components are often controlled. We sometimes see the RHF controller component mentioned.
Right, the controller component is one way to integrate control components from libraries like MUI. It wraps the third-party component and bridges it to RHF.
But is wrapping every single MUI text field with controller the best way if you have hundreds of them?
Probably not. The source material suggests a better practice for scalability. Don't wrap every instance. Instead, create your own reusable wrapper component.
Like a My Custom Text field component.
Exactly. Inside that custom wrapper, you use another hook. Use controller. This hook does the work of connecting the third-party controlled component to RHF internally.
So you build the integration logic once inside your wrapper.
And then everywhere else in your app, you just use your clean My Custom Text field component. It standardizes the integration and keeps your form code much cleaner.
Got it. Use controller inside a custom wrapper is the scalable pattern.
That's the recommended approach.
Wow, okay. This has been a really comprehensive deep dive. We've covered why native React forms often fall short, especially on performance and standardization.
Yeah, the re-render trap and lack of standards.
Then we saw RHF's core architectural win, using refs and uncontrolled components to sidestep those re-renders.
Which is the foundation for its speed.
We walked through the core API, use form to start, register to connect inputs, handle submit for safe submission, and form state for UI flags.
And crucially, the difference between watch for basic subscription and the performance-optimized use watch for targeted updates.
Absolutely. And finally, we looked at scaling complexity. Flexible validation with validate and schemas via resolvers, structuring with form provider and use form context, dynamic lists with useFieldArray, and integrating controlled components cleanly using useController.
It really provides a complete toolkit.
It definitely seems like it. So RHF's foundation is clear. Performance through uncontrolled components. Now that you, the learner, understand these mechanics, here's something to think about.
How does this reliance on refs accessing values directly when needed, rather than reacting to constant state changes? How does that shift how you think about handling side effects in your forms?
Right, like if you need to interact with the DOM directly based on a field, or maybe trigger some other non-trivial logic, if you're not just putting that logic in a use effect hook that depends on a constantly changing piece of React state, where does that effect logic belong now?
How do you orchestrate those effects in a world less reliant on the typical state-driven effect pattern? That's a subtle but really important shift in thinking when you fully embrace the RHF paradigm for modern performant forms.
A fascinating question to ponder. Definitely a crucial shift to consider. Lots for the learner to chew on there. Until next time.